Hello, today we are solving maximum area question, so which is a mathematical methods question. Also is a complex familiar question. So we know maximum area is also something to do with the applications of derivatives. So let's have a look at the question. This is a very useful real life application question. So we got a building material, which is a metal box guttering. So we need to make this guttering to put it between the wall between the two houses, building adjacent buildings. So these are section, this cross section, the box of the box is isosceles trapezium, with the lower base being a 10 centimeters and the two equal slant heights being a 20 centimeters each. So we need to find out the value of the angle between up base and the slant height, so that this cross-sectional area is to be maximum. All right, so we need to also determine that maximum area is what. So I'm going to draw the diagram first before we can understand this question better. So let's sketch the diagram. So we have a gutter, trapezoid gutter, trapezoid shape. So isosceles, so means there's two slant height must be equal. All right, so there's two must be equal, isosceles. They're both 20 centimeters. So that's 20 as well. Then we have a lower base is 10, already given. But we want to know if we want to call this area of the trapezium is called A, so we need to find out the angle between the up base and the slant height. How big we call X, how big this angle is so that this area of trapezium is the maximum, achieve the maximum area. So we need to find so in order to find the X is so that we achieve the maximum area. So we need to establish a relationship or function between A, which is area, and the angle. So we need to have a function first. So in order to use derivative, so we need to establish the function. So area is equal to fx. So we don't know what's the function look like. So let's establish that. So but we know because the area of trapezoid, we use formula called half of the up base plus bottom base times by perpendicular height. So this is the area of trapezium. So we know the bottom base already given, so which is 10 centimeters. So, but we don't know what's A, so we question mark. But we also don't know what's the vertical height. So we don't know, so we call H. So, however, if you look at this triangle here, so you got an X, and this triangle is, the angle is X, it's a right angle triangle. So therefore, we know sine X, sine ratio is the opposite H over hypotenuse 20. So therefore, we know, so we can use H, we can use sine X to represent H. So it's 20 times by sine X. So that's the first formula we established. Now we're going to find out what is the A. So if you look at the A, so therefore, if I'm going to use that section, so this section, what do we call? We might call C. So you can see the C is also using trigonometry, which is trigonometry ratio. I'm going to use cosine. So in this triangle, we also know cosine x. Cos x is adjacent C over hypotenuse, which is 20. So therefore, we know C is, pardon. So C is 20 times by cos x. All right, so we got a C. So therefore, we got two. So A, the total area, total length of the upper base. So A will be 2 times by C plus 10. So therefore, will be 2 times by 20 cos x plus 10. Now, why is it 2 times by C? Because you have two C's. So if I draw on this side, so because our isosceles, we got C as well. This is C. So this is C as well. So then this is a 10, so this middle is 10. So let's simplify. So A equal to 40 cos x plus 10. So let's substitute into the area formula. So the total area. So now we can use the area of the trapezium is equal to half. A is 40 cos x plus 10 plus B is 10 bracket times by height is 20 sine x. So now we establish the function of between A and x. So let's cancel something to the simplest form. So we got 2 cancel with 20 here, it's got 10. So then we will have, so let's put 10 first. So the 40 cos x plus 20 times by sine x. So let's move the common factor out. So it'll be 200. So it'll be 2 cos x plus 1 times by sine x. So you can see my function is a lot simpler than before. So now we have a formula between the x and the A, but we need to achieve what is the maximum area. So how do we achieve the maximum area? So we need to differentiate the function. So differentiate that. So 200 go out. So we can do the product rule. So we know is negative 2 sine x times by sine x plus 2 cos x plus 1 times by cos x. So we will keep going to simplify 2. So it'll be 200 negative sine x squared plus 2 cos square x plus cos x. All right, so now we will have, So you see, if I need to find what x is, so that a is the maximum. So we know we want to find x equal to what? So the maximum area achieved. So now we got cosine and cos. Let's convert sine into cos. So we know sine cos relationship is sine square x is 1 minus cos square x. So simplify to 200. Negative 2 plus 2 cos square x plus 2x plus cos x. All right, now we will get 200. So I'll put 4x, 4 cos square x plus cos x minus 2. So this is our formula. So we will let's solve for x, see what the x is, so that we can achieve the maximum area. So we know, so if when the maximum area is achieved, also is we need to let derivative of a equal to 0. So therefore we have 4 cos square x plus cos x minus 2 equal to 0. So we say, okay, we got cos x squared because it's a quadratic. So if I let y equal to cos x, so therefore this question becomes 4y squared plus y minus 2 equal to 0. So this is a quadratic. Very clear, we can use quadratic formula or using factorizing. Obviously, this one we cannot factorize into 2 brackets because it's the coefficient is difficult for us to do that. So what we do, we're using quadratic formula. So y equal to, so negative b, which is negative 1 plus minus square root of b squared minus 4 times by 4 times by negative 2 divided by 2 times by 4. So the answer will be negative 1 plus minus. So the answer will be 33 divided by 8. All right. Now we got 2 y's. So because we know, so this is a y, which is, so therefore cos x must be equal to negative 1 plus square root 3 divided by, or cos must be equal to negative, now this is a negative value, but we know the x cannot be more than, x has to be acute angle. So because x must be less than 90 degree and more than 0 degree, so therefore we cannot choose, so we say we only can choose 1, so which is the positive value. So negative value is the second quarter, second quadrant, so we cannot do that. So that's so it must be greater than 0. So therefore we go say x equal to cos inverse of negative 1 plus square root 3, 33 divided by 8. So let's give us the x is 0.9 359 radian. So we're using a radian. Now when you convert, so therefore you can convert it to degree. So we know. So you type, yeah, one. So you can convert back to degree, how big are the angle. So convert to degrees. So we know 180 degree is 1 pi radian. It's pi radian, sorry. Pi radian. So therefore, 1 radian is 180 degree divided by pi. So then let's times by, so the x will be 0.9359 times by 180 degree divided by pi. So let's work out the angles. All right, so let's have a look at my calculations. If I'm going to use calculator, so we will use calculator 0.9359 times 180 and divided by 3.14. Sorry. Sorry, I'll just start again. Press the wrong button. So 0.9359 times by 180 divided by 3.14. So the answer is 53 degrees. So approximately equal to, so 53.2 degrees. So you also can change your calculator to degree format, so you can find that. So therefore, we have the maximum, the angle achieved. So what is the area? So the maximum area will be substitution. So we know is 200 times by. So the area formula we know is substituting to this equation. So we just put into sine 0.935 radian times by 2 times by cos. Substitute original equation for the with the sine with the area and the x relationship. So the answer is about 352.03 centimeters square. Okay, so that's the final answer. Thank you for watching. Hopefully you have got some information how you solve maximum area using derivatives. So to summarize for the question is, try to, when you solve the area formula, you must establish a relationship between the area and the angle. In this question is something to do with angle and the area. So this is our critical thinking. So if you're on the right track, you should establish a equation or relationship between the area and the x given. Thank you again. Bye.